Of course, plastic fascias, like in many places in Australia where you don't have any fossils. So it's some kind of a problem. But of course, this affects also of these climate fluctuations on cephalopods are important because they show that there's also within the whole food chain there seems to be some kind of a problem, and also in the plankton there is quite a turnover. So this kind of hothouse conditions we can see again and again. There was this paper in Science by Sun et al. About the early Triassic, and also Pal Ges presented a talk here where he showed at the end of the Permian this really dramatic increase in paleo temperatures. And so, well, just an example also an example from the Devonian with respect to hot temperatures and extinctions. This is a diagram published by Michael Jopinski and others, and they show that there is a dramatic decrease in oxygen values around the Franian-Flammanian boundary, and this decrease in values, of course, if you see this is 1 per mil, that means a climate warming of 4 degrees Celsius. So there is quite a warming trend here. These are some of the hottest temperatures in the Devonian, and if you translate this in this kind of temperature curve, you could also see that at this time interval we run into these problems that the first breeds start to die out here, where we have this kind of warming. And then in this time interval, the reef belts virtually start to disappear. So just to say as a resume for this climate warming, of course, I think it goes hand in hand, because these also have been mentioned as certain factors, separate factors, but I think they are all interconnected. So deoxygenation, ocean acidification, all this goes hand in hand with climate warming. There was this paper by Hönisch recently, and also if you look to the physiologists like Gertner, who works extensively on these questions, they show how faunas are affected if oxygen levels drop down. And well, so just to conclude, I just want to say that, well, when we have all these major innovations and these dramatic changes, I think all these different factors play a role. As I said, biological factors and the classic geological factors, but of course something like climate has a major influence. And what it is pretty clear to us after all these years of research is that we don't have any kind of a long-term greenhouse and just a short-term glaciation. Instead we have really a long period of changing climates, of cooler climates in the upper Ordovician, early Silurian, peaking into glaciations. And yeah, I think if we want really to understand all these changes, we have to deal with all these dramatic climatic changes. And yeah, as you have seen at the end, is also that I feel that extreme climate warming triggers many of these faunal overturns and extinctions. So, but it's also pretty clear, also within our IGCP projects, that of course we really collected a lot of data, but it's just a starting point, and that it's more to be investigated to find out more about the complexity of all these triggers. And yeah, I mean, this is just to end with the talk. So I think global warming, yeah, of course, is one of the triggers, at least one of the major triggers in this phase. Yeah, thanks a lot, Oli.